Hello students, this is the Digital Knowledge Irshad Academy with a new video of open loop gain. Before going to circuit description, subscribe my channel, press bell icon for the next video. Looking at the circuit, it is open loop gain. See that R1 upper end of R1 was connected here across output control generator and it was forming a voltage divided network. The output voltage across R2 was taken as a feedback at the input to stabilize the gain. But in this case, upper end of R1 is disconnected from this place and connected to ground. Now the R1 becomes in parallel with R2 and the feedback loop is open. Now let us make few calculations. We are going to calculate the current which is flowing in the input circuit to ground. From this ground through Zi comes here and divides in both branches and to ground. Let us see, I is equal to Vs over Zi plus R1 into in parallel with R2. This can be written as I is equal to Vs over Zi plus R1 into R2 over R1 plus R2. This is called a product formula and it is applicable in parallel resistance. When two resistances of equal value are connected in parallel, total resistance becomes half of the individual value. We can calculate 100 kilo ohm, 10 kilo ohm, 10 kilo ohm multiplied by 10 kilo ohm divided by 10 kilo ohm plus 10 kilo ohm, and it comes equal to 100 divided by 20, which is 5 kilo ohm, and it is half of the individual value of resistance. Now this is the value of current, Vs divided by Z plus R1 and R2 in parallel. Now we want to find out the voltage across Zi. We will multiply this current with Zi and will get the input voltage called V input, and now V input is equal to Vs divided by Zi plus R1 into R2 over R1 plus R2 multiplied by Zi, or we can write this V input is equal to Zi over Zi plus R1 into R2 divided by R1 plus R2 into Vs. This is the value of input voltage. We know that output control generator or V0 is equal to A V input. Now by putting the value of V input A into put the value Zi over Zi plus R1 into R2 divided by R1 plus R2. This is V0 multiplied by Vs. Let us bring Vs on this side, and this V0 over Vs is equal to Zi over Zi plus R1 into R2 divided by R1 plus R2. Now output voltage divided by source voltage is nothing but gain without feedback. Gain without feedback, which is called A naught. We can write here A naught is equal to A Zi over Zi plus R1 into R2 over R1 plus R2. If R1 in parallel with R2 is small, then Zi R1 into R2 over R1 plus R2 can be neglected. Now we can neglect this. Z1 cancels with this Zi. We are left with A naught is equal to A. What does this mean? This means open loop gain A naught depends entirely on op-amp operational amplifier gain. Open loop gain is equal to gain of the operational amplifier. Let us go to summary. Upper end of R1 is disconnected. We have disconnected from here and connected to ground. We say that feedback loop is open. There is no feedback taking place. Previously, the voltage was developed across R1 and R2. Output voltage across R2 was taken as the feedback voltage. I is calculated as the source voltage divided by Zi plus R1 and R2 in parallel. This can be written as I is equal to Vs over Zi plus R1 into R2, R1 plus R2. This is the product formula for parallel resistances. This is the value of current. When we multiply with the input impedance, this will give voltage across Zi will become our V input voltage. V input voltage is equal to Zi into Zi plus R1 into R2 over R1 plus R2. Now this is the value of current. This is the value of current multiplied by Zi will give us the voltage. Ohm's law is equal to I into Z or R. This is current. We know the value of current multiplied by Zi gives us V input. We know that output voltage or the output control generator is equal to A V input. By putting the value of V input, A is this A and this is the value of input current. We can take Vs out and it becomes V naught over Vs, which is open loop gain is equal to A Zi plus R1 into R2 divided by R1 plus R2. If R1 is in parallel with R2, combination is small than Zi, R1 into R2 divided by R1 plus R2 can be neglected, and we have neglected this, and Zi cancels with the Zi. A naught is equal to A, which indicates that A naught gain without feedback or open loop gain. This is called gain without feedback or open loop gain. Depends entirely on gain of operational amplifier. That's all. In the next video, we'll discuss logic circuits. Thank you very much.